Hey guys, today we're going to work on addition and subtraction formulas. Basically some more identities based on addition and subtraction of sine and cosine. So here we go. This slide right here is everything you need to see and know. You need to take a picture of it, write it down, do something. You're going to need these formulas for every single problem you do for the next 2 days. So get those down somewhere. Or just memorize them if you want. Okay, sine of addition, you break it up like this: sine cosine plus cosine sine. Sine subtraction, sine cosine minus cosine sine. If you do cosine addition, it's cosine cosine minus sine sine. Cosine subtraction, cosine cosine. See, there's just so many of them. Tangent looks like this, and that, addition and subtraction. I may show you where these come from in class tomorrow. I haven't decided for sure yet, but the main thing is I need you to see them and be able to use them. All right, so let me show you about 3 examples here. First one says find the exact value. Now this may be the hardest thing we do today or tomorrow. And it says find cosine 75, the exact value. Now cosine 75 is not one we know, but we can. What you got to do is you got to break it down with terms that we know. For example, we know 40 degrees and 35 degrees. So that's how I'm going to. Sorry, we don't know those. That was crazy. Just messed that one up. This is live video as usual. I know 45 and 30, and 45 and 30 add up to be 70. So I'm going to do the cosine addition that you saw in the last slide. And if I break it up with the cosine addition formula, I'll get cosine 45, cosine 30, minus sine 45, and it is minus, by the way, that is the formula, sine 30. Now, cosine 45, square root of 2 over 2. Cosine 30, square root of 3 over 2. Sine 45, square root of 2 over 2. Sine 30, 1/2. If you multiply all that out, over here you get square root of 6. Over here you get square root of 2, and both of them are over 4. There's your final answer right there. Square root of 6 minus square root of 2 over 4. And you're going to see answers that look like that a whole lot. Okay, let's look at one more of those. The next one's in radians. It's cosine power 12. Now it's 1 power 12, so I'm thinking I'm going to have to subtract this time. And this is where it's going to get crazy. You got to try stuff until you find something that works. Pretty sure that power 12 is really power 4 minus power 6. Let me think about that. Power 4 is really 3 power 12. Power 6 is really 2 power 2. That's exactly what it is. So because 3 power 12 minus 2 power 12 is 1 power 12. And guys, you're just going to have to play with that until you get it. This is cosine subtraction. So I'm doing cosine, cosine, plus sine, sine, and I'm going to work it out. Cosine power 4, square root of 2 over 2. Cosine power 6, square root of 3 over 2. Sine power 4, square root of 2 over 2. Sine power 6, 1/2. What that gives me, my first part gives me square root of 6, because 2 times 3 is 6. The second part gives me 2 times 1, which is square root of 2. Both denominators are 4, so you can put it all over 4. And there you have it. Okay, so make sure you have those formulas written down. The toughest thing you're going to do is try to figure out how in the world to write power 12 with either power 2s, power 3s, power 4s, power 6s. Same thing with 75. How do you write 75 with 30s or 45s or 60s or 90s? Because those are the values that we know. All right, we're going to go from one of the hardest things we're going to do today to one of the easiest things, and that is this. It says find the exact value of this expression. What you're going to do, you're going to match it up, okay? Look back at your formulas you wrote down or took a picture of or whatever, and I'm looking for sine, cosine, plus cosine, sine. Sine, cosine, plus cosine, sine. And when I find it, it's this one. You should have written this one down. That's the one it is. It's sine of addition. Because it's sine of addition, that's the 20 is your S, the 40 is your T. So I would do 20 degrees plus 40 degrees, which everybody knows is 60 degrees. And everybody knows sine of 60 degrees is square root of 3 over 2. And there's the exact value of that expression. Much, much easier going backwards than it is going forwards. All right, another thing they're going to have you do, they're going to have you prove identities are true. This is an identity we've seen before. This is the cofunction identity. We talked about if angles add up to be power 2 or 90 degrees, they're equal, like cosine and sine are equal, or tangent, cotangent are equal. But what I see here, I've got to make this side, I'm proving an identity, look like sine. That's what I've got. That's what's got to happen. And I'm seeing cosine subtraction. Well, cosine subtraction is cosine, cosine, plus sine, sine. Watch how quickly this thing takes shape here. Cosine power 2 is 0. So I'm going to do 0 times cosine u. Sine power 2 is 1. So 1 times sine u. And look at that. 0 times cosine, that's gone. 1 times sine u, sine u. Guys, just proved it in 3 lines. All right. This side, that is that the identity is true based on the formula we're using today. Let's do another one of those. Verify. I'm using this one. Okay, tangent power 4 plus x. We haven't used the tangent one yet. Look back at your formulas. You have a tangent addition, and it's tangent of s plus t, or tangent power 4 plus tangent x on the top. My denominator is 1 minus tangent power 4 tangent x. Guys, and I'm just copying that straight from that first slide. So I hope you wrote that first slide down. Tangent power 4 is 1. Okay, so the top, look at the top already. It's 1 plus tangent x. The bottom again, tangent power 4 is 1, so I get 1 minus 1 times tangent x, which is exactly what that is. Okay, so again, 2 lines. I actually wrote it in 1 line, but 2 lines, pretty quick. One more slide. I was kidding. There's nothing on that slide. So we're done. All right, so not bad. We're just using those formulas over and over and over again. The hardest thing you're gonna have to do is try to make numbers into numbers that we know, into values that we know. Okay, so hope that wasn't too bad. Can't wait to see you tomorrow. Adios.